In the packet that you got yesterday, on the second page, well, actually, the first page still, here is what we were doing. Looking to find area under the curve, we need to use an approximation. Areas of rectangles seem easy enough. We need the width and the height. And this problem said from x equals 1 to 2, 1 to 3, which is 2 units, but we wanted to create 4 slices. So each width of those rectangles is half. And here we made the calculations quicker by factoring out that half right here, and then finding the heights for LRAM, the height at 1, the height at 1/2, the height at 2, and the height at 2.5. That's how we get area under the curve with left rectangle approximation method. Here is the approximation with the right. And again, we've now shortcut entirely. The width of each of these is the same, so I'm going to factor that width out. And then finding the heights using the right endpoint. The curve is underneath here. And we're finding the right side and choosing the height that way. And then the one you don't like, midpoint, where the x value is 1 1/4 and 1 3/4, 2 1/4, 2 3/4. But again, find the area of each rectangle and add those 4 rectangles together to get your approximated area under the curve. So I would like you guys to now start in the packet and do these problems. Number 2, using this equation. I've drawn in the rectangles, you should draw them in as well. And 3 subintervals from 2 to 8. So the width of each rectangle is 2. For LRAM, use the left side and plug it into this equation to get the height. So this height is f of 2. Then times 2 gives you the area of this rectangle. This height here is f of 4 times 2 gives you the area of that rectangle. This height, using LRAM, that is f of 6 times 2 gives you the area of that third rectangle, and add them together. Now doing the same process for RRAM, same picture, same slice from 2 to 8, but we're going to use the right end for that height of the rectangle. So this is f of 4, this is f of 6, and f of 8 is 0, so we are actually adding that in, but it's a 0. So this one is easy to calculate. It's just 2 rectangles. 2 times f of 4 plus 2 times f of 6 gives you this approximation. And then the midpoint one, where the height is found using the x value in the middle. So we need f of 3, f of 5, and f of 7. So go through and do those calculations. I want to see work on your paper. I will check it on Monday. We do also need you to know if your estimation is going to be over or under. And as we discussed in class yesterday, it depends on what kind of estimate you're doing, left or right. I'm not going to ask about midpoint. And if the function is increasing or decreasing. I recommend you draw the graph. Here's the graph. If we were doing left end, those rectangles are underneath, and it's going to make an under approximation. And the AP exam will ask why. And RRAM will be an over, because the function is increasing. And I wrote this explanation differently. I used the derivative is positive. That means the function's increasing because the slope is positive. That's the translation. Then it's the reverse of things if it's decreasing. If it's decreasing, LRAM creates an over approximation when f prime is less than 0. That means when the function is decreasing. And when the function is decreasing, we're using RRAM, it will be an under approximation. The function is decreasing. Okay, so some people are unhappy that rectangles are too blocky and chunky, and maybe it's better if we use a trapezoid. And recall the area of a trapezoid is 1/2 the bases added together times the height. The bases are the lines that are parallel, and the height makes that 90-degree angle. And then the other side is just something else. The thing that will annoy you is these trapezoids are going to be sitting on their butt. And we're going to have to calculate the height of base 1 and base 2 using the equation of a function. So let's look at this problem. Here's the equation y equals x squared plus 1. And we're going to just find the area with 2 trapezoids. So the area of this trapezoid, base 1 is f of 0, base 2 is f of 1/2, and the height is this thing laying on its butt is 1/2. The area ends up being 1/2 base 1 plus base 2 times height, which is here. And this is the other one, 1/2 base 2 plus base 3 times the height. And then all added together, this comes out to be about 1.375. We're going to do the same thing we did before. And we are going to make 4 trapezoids from 1 to 3. So over these 2 units, I need to cut it into 4 pieces. Each slice needs to be 1/2. And we're going to make these trapezoids. We're going to connect those straight lines. And it is much more accurate because not as much of a chunky block of a rectangle is hanging over. So pause the video and do those calculations. The area of trapezoid 1 is 1/2 base 1, which is f of 1, plus base 2, which is f of 1.5. So 1/2 base 1 plus base 2 times the height. The height is this skinny sliver, which was 1/2. So that's the area of trapezoid 1. You go through the calculations and find the area of trapezoid 2, 3, and 4. Add them all together. Work through problem 2. You can use a calculator. Find 3 trapezoids, add them together. And I wanted to show you that this can also be done if they give you a table. Reading the problem. The rate at which customers are being served at a Starbursts is given by the continuous function r of t. And here's a table of selected values from 0 to 10 hours. And they want you to use a trapezoid with 4 subintervals. So this is going to make a trapezoid. This is going to make a trapezoid. That's a trapezoid. And this one is a trapezoid. We could briefly graph this. Don't know how helpful that will be, but let's graph it. 0, 2, 3, 6, 10. Notice the widths of the trapezoids are not equal. And we have 0, 37, and 2, 44. Here's my first trapezoid. The area of this trapezoid is 1/2 this width, which is from 0 to 2 units long, plus base 1, which looking at the table, that one is 37, plus this base, which is 44. That's the area of trapezoid 1. Trapezoid 2 is going to be right here, 3 and 36. One half the base, the difference between 2 and 3 is 1 unit. So trapezoid 2, the height here at 2 is that one's base 1, and this height here is this guy's base 2, so we're going to add 44 and 36. And trapezoid 2 gives me a 40, and this next one, there's a big jump. Trapezoid 3 is 1/2 the base. The difference between 6 and 3 is 3 units. And the height here for this base 1 of this trapezoid is the height at 3, which is 36. And this guy, which is a height at 6, that's 42, which gives us 117. And last, the fourth one, here's trapezoid 4, 1/2 times the base. Difference between 10 and 6 is 4 units. The height, the base 1 of this trapezoid is 42. The base 2 of this trapezoid is 48, which gives us 180. And then adding all 4 of those together, and checking trapezoids, if the curve goes like this and I'm putting a trapezoid in it, when it's increasing, I had an over approximation, and when it's decreasing, perhaps whether it's an over or under approximation doesn't matter about whether it's increasing or decreasing. Maybe it's more about how curvy it is, its concavity. Second derivative is what determines whether the trapezoid rule is an over or under approximation. Here, if I just did one trapezoid to approximate this, if it's concave up, the trapezoid will be over. So trapezoid estimation gives an over approximation when it's concave up, and it will give an under approximation. Complete the packet as practice. So I will be checking page 2 and page 6 on Monday, as well as the Delta Math. And you will have an exit card on Monday that will ask you about, is this an over or under approximation, and asking why. Those are the things that are included in the packet on page 5. You are going to be responsible for those as well. All right, have a good day. Happy weekend.